Children, today we are going to learn about hybridization. First, what are you going to see is about what is meant by hybridization. Hybridization is the process of mixing of atomic orbitals of the same atom but with comparable energy. That is S, P, D, F. There are 4 different type of orbitals. These 4 orbitals get mixed. They are having comparable energy to form equal number of new equivalent orbitals with the same energy. First we have seen comparable energy S, P, D, F. Then the 4 orbital get mixed and giving equal number of new equivalent orbitals with the same energy. The resultant orbitals are called as hybridized orbitals and they possess maximum symmetry and definite orientation in space. So there are different types of hybridization: SP, SP2, SP3, SP3D, SP3D2, SP3D3, etc. One by one we are going to see. First we are going to see about SP hybridization. Example is beryllium chloride. You know beryllium, atomic number 4, configuration 1s2, 2s2. Outermost electron, valence electrons, 2 electrons. So in the ground state, 2s, 2s2, both having opposite spin. 2 electrons according to Pauli's exclusion principle, both the electron having opposite spins. So 2s having 2 electrons, it is in the ground state. Now this beryllium chloride, B is the central atom and 2 atoms on both sides of the beryllium. This is in linear shape. So here at the excited, this is the ground state energy. Now in the excited state, one electron from the 2s orbital, this is 2px, 2py, 2pz, S having only one orientation, so I have drawn only one box. P having 3 orientation, px, py, pz. All the p orbital having double shape, already have learnt. S orbital having spherical shape. So in the excited state, S electron from the 2s orbital jumps to 2px orbital. So now 1s and 1p. One electron from here, it jumps to p. So 1x and 1p get hybridized. sp hybridization giving 2 hybrid orbitals sp, each having 1 electron. You know S is spherical in shape, P is double in shape, this is X, this is Z, this is in Y direction. When S orbital, P orbital get overlapped, we'll get the shape like this. Get the shape like this. So the SP having 50% S character and 50% P character, both combined and giving a structure like this, the geometry for beryllium. beryllium having 1 electron. Now having 2 chlorine atoms, chlorine atomic number 17, 1s2, 2s2, 2p6, 3s2, 3p5. 3p5, p having 3 orientation, x, y, z, 5 electrons. According to Hund's rule, pairing starts if all the orbitals having 1 electron each. So 1, 2, 3, then starts pairing 4, 5. Z orbital is having lack of 1 electron. So beryllium hybridize overlap with the Z, 2p Z, sorry 3p Z orbital of chlorine. So p means dumbbell shape, another p is dumbbell shape, chlorine, that is 2p Z, 3p Z orbital, 3p Z orbital. So chlorine also giving 1 electron here and 1 electron here. So this is the linear shape. This is called sp hybridization. Now same we can see for sp3 hybridization, sp2, best example pf3. Boron is the central atom, atomic number 5, 1s2, 2s2, 2p1, outermost having 3 valence electrons. So energy level, ground state 2x, 2p, px, py, pz, 2px, 2py, 2pz. Here 2s having 2 electrons having opposite spins, 2p having 1 electron. This is the ground state. Now in the excited state, one electron from the 2s orbital jumps to 2py orbital. So hybridization S P1 P2 sp2 hybridization. So 1 2 3 sp2 hybridized orbitals, 1s and 2p. So sp2, 3 sp2 hybridized orbitals. So structure, if you are seeing, means it takes the trigonal planar geometry, that is it is in 120 degree. This is for boron, sp2 hybridized orbitals having 1 electron. Now fluorine, 3 fluorine atom, atomic number 9, 1s2, 2s2, 2p5, outermost 2p5, px, py, pz, 3, 4, 5. Pz is having only 1 electron, so it forms a covalent bond with this pz orbital. So 2pz orbital of fluorine giving 1 electron, 2pz orbital of fluorine, 2pz orbital of fluorine. This is sp2 hybridization. sp2, then having 1 electron, it bonds with the fluorine, forming a covalent bond, 3 covalent bond.